Thanks for tuning in to the Lean 911 podcast, where you'll have a voice directly from the Gemba. I will rely on my 3 decades of Lean successes, as well as my failures, to answer your most challenging questions regarding your Lean transformation. I'm your host, Mark DeLuzio, President and CEO of Lean Horizons Consulting, and the Principal Architect of the Danaher Business System. Looking forward to your questions. Now, let's go to the Gemba. Hi, welcome to episode 28 on the Lean 911 podcast. I am fortunate to be joined by Jon Boucher, who just retired from General Electric after, I think, 78 years of a career there. And
felt like it, Mark.
Yeah. And I've known Jon for a very long time. Jon, to me, is one of the best Lean professional, perhaps not only in the country, but in the world. And he, like me, has worked with the originators of the Toyota production system, albeit Shingijutsu. And in particular, he was a star student that was taken under his wing, a guy named Chihiro Nakao, who was one of the originators working directly for Taiichi Ohno. And Nakao was just a special breed of consultant. And we'll talk more about Nakao as we get in. But Jon has recently, over the last year, joined Lean Horizons as managing director. And we're thrilled to have him on our team. And he's already doing some unbelievable things. He was over in India with me about a month or two ago, and he's doing some good stuff. So anyway, Jon, we're going to be talking about 3P, which is known as the production and preparation process. Not a very sexy name, is it? And moonshine. That's a little bit more intriguing, I think. And you'll talk more about moonshine.
I love moonshine.
You want to talk a little bit maybe about your background in terms of how you got in with this with Nakao and what's so special about it, and go from there, and maybe a little bit of background as well.
You know, Mark, look, I consider myself a student. First and foremost, I love to learn, and I love to learn from great teachers. And even going back to when I first met you, I learned a lot in that first engagement when we were working actually in a finance company. Me being a manufacturing guy.
GE money, yeah.
Hey, so look, I think that maybe I go a ways back. I am an engineer. I'm a mechanical engineer, graduated from University of New Hampshire. But prior to that, I did a 4-year tool and die apprenticeship. So part of that apprenticeship, you know, I love all things mechanical, everything about manufacturing. But also, I had to become a student, not so much a scholar, but somebody who could listen to experts, somebody could take advice, somebody that had to learn to accept constructive criticism. Sometimes it wasn't always constructive. Learning from crusty tool and die makers. A lot of the guys my grandfather's age were teaching me at the time. This is in the early 80s. And you know what? So I did my apprenticeship. I then went to the university. So I did eight years of school, if you will. And it served me well when I met Nakao and some of the other senseis for the first time. They were critical of the operations. And for me, rather than be offended, I heard that as an opportunity to improve. So I think early on that set me apart from maybe my peers who were maybe susceptible to the criticism. I took it personally. I just took it like I was still an apprentice and I was learning. And I had a great teacher that was saying, hey, you really need to think about this. You need to think about that. You should maybe start over here, reinvent the process. All things that were natural to me. So that's how I got started.
Well, you not only had a great teacher, you had the best in the world at what he I mean, he invented it. I mean,
he did. I think everything we're going to talk about came out of his head.
Right.
Yeah.
Right. Good point. By the way, I thought every executive was open to criticism.
Oh, of course. That's always the way, isn't it?
Okay. Okay. Maybe I'm wrong. Okay. Well,
you know, Mark, I mean, you've got to have thick skin to get through some of this, but it's mostly with love. Look, they don't poke the guys that they can see don't want to learn.
Right.
Yeah.
Well, we took it as a badge of honor, and Nakao would fire me 4 or 5 times a day.
Yeah.
But at the end of the day, he'd hire me back. Just to be fired again the next day.
Yep. That's right.
So, well, Jon, okay, so let's talk about this. I think I'd like to talk a little bit about the idea of what 3P is. Again, it's not a sexy name. Production, preparation process. And I was lucky enough, by the way, I think to do the first one in the USA in like 1990, 91. I was in charge of the Asian business team at Jake Brake, and I had Hino Motors as a customer. And as you know, Hino is owned by Toyota. And not only did we learn from Nakao, but they worked together with the Hino engineers. And it was an unbelievable experience for me, not being an engineer, right? I got to see Nakao in action on the whole 3P thing. And like you, he took me to Japan and showed me some of the things he did over there. I don't think I spent a considerable amount of time with Nakao over the 12 or 13-year time frame that I was at Danaher. But I think you probably hold the record in that regard because he took you under his wing specifically to teach you. And I don't know if people really know who Nakao is, but it's an unbelievable honor. And just to give everybody an idea how meaningful this guy was to his clients, he single-handedly turned Porsche around. And the CEO of Porsche gave Nakao the last car on the production line of that particular year as a gift. And I got to drive in that car. It was a red Porsche.
It was a 928, right?
Yeah. And he picked me up at the airport, and it had Nakao inscribed in the seat and on the floor mats. That's how much they thought of this guy. He actually saved them. And it's the first time, John, I saw navigation. It's like in the mid-90s, first time I saw navigation, okay, ever, in a car. It was all Japanese, but, kanji characters, but first time I saw navigation.
Yeah.
But anyway, this gives people an idea of the gravity of who this guy is.
And Mark, I think what goes with that is when you have somebody that is the best in the world, at times they can be tough to learn from.
Oh, yeah.
They've got their own way to think and their own style and their own style of teaching. So look, he's not for everybody, but for the people that he had a synergy with, he would give you more than you could ever absorb. And I think the downside of working from great or learning from great people like that is there's too few people that have the opportunity to learn, which is a downside, I think, right? So there's not 100 people that understand this. You can count all the people on one hand. And I think part of that is, part of that is access to them. But the other part is, look, the teaching style can be a little tough. You've got to be really resilient and serious as a student.
Well, yeah. And again, we took it as if he's going to give us a hard time and call us a concrete head and fire us 3 or 4 times a day, that was a badge of honor for us that he cared about us. Because if he did not think you were willing to learn, he'd walk out the door, literally. And okay, so, and he's done that. And so has Iwata and some of the others. So, well, John, let me ask you, why don't you frame up a little bit for people who may not know what 3P is and moonshine, because they go together. And by the way, we're not talking about the drink that they make down in the South, but it's called moonshine. But go ahead, John. Why don't you give us a little bit of an overview of what this is all about?
Sure. Yeah. Why don't I start with 3P? So 3P was the first toolkit, if you will, that I was exposed to. So the production preparation process, and like you said, it's not a very catchy name. I would say there's a name that, or an acronym that connects to that, NPI, New Product Introduction. So we were doing new product introduction. And what Nakao did is he said, I'd like to teach you 3P. And on the surface, it seems like, well, we already do that. But let me do a bit of a compare and contrast. So what we used to do, we call it new product introduction. It might be a design change, a design update. I was in the aviation business at the time. It could be a new engine coming out. So there's a new component. I had certain characteristics associated with it. What we would do is we would make the first set. The act of making the first set, we called new product introduction. So some of the parts might be handmade. Some were made using fixtures and machines. So the engineers would determine what's my tooling need, which machines do they go on, and it was all batch and queue, of course, Mark. So you start fighting on equipment priority with other parts. Then what we would do, you'd make the first set, you'd roll up the cost, and we would say, it costs this much. And then the name of the game for the out years was, let's work down the cost curve. What Nakao said is he said, hey, we're going to come at this from a totally different angle. We're going to do target costing first. Where do you need to be? Who's your customer? Oh, well, we might mention an airline. He'd say, okay, that's the end user, but your customer is design engineering. So where are they? And it's the first lesson. Oh, they're not here. They're half the country away. You should have them here. So we started to learn the value of having everybody in one place. And I'll just tell you what that helped us with was it was more than here's the design engineer, the design intent. Very, very important, the design intent. But also the engineers were learning from us. What does it mean if you put plus or minus 1,000 on a blueprint for tolerance? And a lot of these engineers had never worked with their hands or worked in a machine shop, and they weren't really sure what plus or minus one meant. So those were the first few big breakthroughs. But what Nakao taught us is the value of having the design engineers with us is let's make sure we understand design intent before we start talking about process, which comes before you start talking about machines. What's the design intent engineer? So we would sit down and understand that. What are the thermal characteristics? Anything associated with a new part. And then what he said was, hey, if you do what you did, you're going to get what you got. He didn't use those words. That's a Boucher phrase that I'm sure you've heard before. But his point was, why don't we start fresh? How do you know if you need that VMC or a broach or whatever machine? You don't know. So what you should do is you should experiment and you should understand your CTQs, your critical to quality parameters, and experiment and figure out what is the best method. And that's when we were first taught the lean priorities of safety, quality, delivery, cost. And he taught us to think that they're not categories, they're priorities. And also the whole notion of quality and cost. Mark, you and I might have talked about this before, but you need both. It's not an either or, it's both. You have to have perfect quality and you have to have low cost. But what he taught us was the value of experimentation to understand what process should I select first, then what machine would I do that process on second. And it also led us to, even while we're in the design phase or the introduction phase, that's the time to set the line or the cell up. All happens simultaneously.
John, I've seen so many companies that focus on productivity.
Yeah.
Even when it's only 10, 12% of their total cost. Okay. And for some reason, there's a big push to look at that. And what I try to explain to executives is that productivity and cost in general is a byproduct of doing the right things when it comes to quality, safety, quality, right? Even lead time and obviously lead time, if you're making them batch, you're going to have long lead times. Okay, we got that, right? But assuming you're going to convert over to a flow type or pull as a second option system, you're going to get cost. Okay. And it's usually the processes that drive the bad cost, okay, and or high cost. And it's not like that Joe operator doesn't want to work hard. There's nothing to do with that. Matter of fact, they want to have nice, easy processes that work all the time and not have problems during the day. So in a sense, it's disrespectful to the operator if you're not going to be putting time in to driving good, sound processes, right? Now you had a saying the other day that came out, which I thought was mind-boggling to me. You had a saying about the purpose of a line or a cell. Why don't you tell us what that?
Sure. In Mark, I think this is counterintuitive against what a lot of people teach. The sole purpose of a line or a cell is to expose problems. There is no second purpose. And so let's think about this, because this goes back early on. I'm sure you had the same experience. The first time we set up a line was a simple line, and we turned it into a type called the chaku chaku. I know you know what that is, the load load.
Load, load.
And the first series of complaints started to come from maintenance. Hey, what are you going to do when that machine breaks down? And that's when I first started to understand, under the guidance of a coach, the intent is to not have a backup, to make sure that maintenance maybe gets turned upside down and starts to measure themselves on making sure equipment doesn't break rather than how fast can they fix it.
Yeah. Yeah.
So the whole thing in my mind, I could start to see the forcing function, just the way a moving line is a forcing function to get your output,
Mhm.
one purpose. But the line is a forcing function to make sure that we get everything right the first time and we meet the CTQ. So if a machine breaks down, it exposed a problem. And the answer is not get a second machine. I know you know that, but hey, that's a tough pill to swallow early on.
Well, yeah,
Fixtures
on
not.
one of my
Yeah.
previous podcasts on problem solving, I had like a 6-part thing on problem solving.
Yeah.
And one of those episodes, I forget which one it was called problem fixing versus problem solving.
Yeah.
So, the example I use is, let's just say a PC board blows in a controller somewhere, okay, on some
Yep.
CNC. Is the problem really how quickly we can get that PC board to be replaced and get the machine back up and running?
Yep.
Or is it to understand, why did the board blow? Why didn't we know about it in advance? Do we have an IoT device, for example, that could sense a heat increase on the board? Or,
Yep.
and then why didn't we have the part in stock? Is there's another problem there? We don't have the part. Okay.
Mark, I'm just smiling because I think what happens here, this gets to another pet peeve of mine, I think yours too. Maybe in the last few years, you see a lot of these Gemba boards and you have metrics. So a metric in that case would be like this mean time between failure and mean time to repair. Those aren't good metrics.
No.
Did
There's a rework.
it-
There's a rework metric.
Right. Exactly, Mark. Yep. And so I think that no matter what, especially the teams I've coached in the last few years, I really wanted them to understand that that line has a purpose, and the purpose is to expose problems. And then our job as leaders is to help solve those problems, not fix them, to your point.
When you learn from the best in the world, the guys that pretty much invented it, right?
Yeah.
Okay. I really cringe when I hear people say, well, lean is just common sense.
Yeah.
It's counterintuitive. It's counterintuitive. When I tell you, oh, you need to do more changeovers. Well, wait a minute, all our lives we've been trying to do less changeovers. No, you need to do more, because customers don't order based on how you decide to produce.
Exactly.
Make A's and next week I'll make B's, right?
Yep.
That's not how they order. And so it's counterintuitive. All this stuff is counterintuitive, right?
So, yes. So, Mark, can I give you a counterintuitive example?
Sure.
I might be getting ahead of myself. Let me delve into the area of moonshine.
Okay, so let's talk about moonshine.
Okay.
By the way, later on, I want to talk to you about battleships, and maybe you can incorporate that into the, maybe that's where this goes, right?
Well, let's see if this fits. Let me give you my
Okay.
counterintuitive example.
Okay, moonshine. Talk about moonshine. Talk about the history. Talk about what it all means.
Okay. Okay. And maybe, okay, I'll get to my example, which the reason this is in my head, it was the defining moment in my career.
Okay.
This example I'm going to share with you.
You had more than one shot of moonshine. Is that what it was?
Yeah, I should have had more than one shot of moonshine.
Okay.
Yeah.
Go ahead.
No, so look, with the moonshine, so we get started with 3P. We get started with 3P. We start to change the way that we did new product introductions with the guidance of the coaches. That was great.
Right.
And then there was a point in time where Sensei Nakao said to myself and my boss, who, by the way, was a great student too, and he and I were like this for our whole careers.
Yeah, you and Todd are in my top 5 to 10 lean people that I know personally.
It was just one of these matches that I don't know. We just went together, right? We complemented each other in so many ways. So here's Nakao one day, and he just took a look around. He was giving us some tough coaching, and he said, "You know what? These processes here, are so bad. They're so bad, Bushy. He always called me Bushy. They're so bad, Bushy, you should just start over. I said, okay. And he said, I mean, literally start over. You need to do moonshine. What's moonshine? And he said, your engineers here, they think they own every process. They gave you the processes. Maybe some are dead. I don't know. But they gave you the process. So they're going to defend everything. And they're going to kill you guys if you try to change it. What you need to do is you need to make a place here where you can go under the cover of darkness like the Kentucky Moonshiners and reinvent your process. And that was the first I ever heard about it. And so we started to learn more about it, and there was a process associated with it. So I think there's a misconception, Mark, that this is just a place off to the side. It's more. That's the way to get started, right? But there's more. So the misconception is it's kind of a playpen. You turn a couple people loose, they're creative, and they can go do something. Where actually there is a very rigorous process associated with moonshine that was modeled after Thomas Edison's Menlo Labs. And so that was one piece that you've got the rigor of experimentation. So we talk a lot about, I know Lean talks about the scientific method, the rigor of experimentation. What's my hypothesis? How do I experiment? How do I draw a conclusion? What's my next step? Coupled with the creativity. So Nakao had both sides of the brain, and he loved to talk about both sides of the brain and how they can be conflicted with each other, but you need both. So one side of the brain, you might be a linear thinker, you might be technical, very good at math. The other side of the brain is more creative, and you've got to figure out how to marry both. So as an individual, how do you marry both? Or as a team makeup, how do you get both on the team? You need both. You need a lot of different types of personalities on the team. So the other piece here with the creativity, a lot of the inspiration that Nakao would point to was Kelly Johnson with the Skunk Works. So Kelly Johnson was a brilliant plane designer, the U-2 spy plane, the SR-71. I think a lot of people know the Skunk Works. But it was both of those put together. But what he did is he brought the rigor to it. And it's not just what I mentioned. There also was another element where this is not for everybody, but the element on looking to nature. So as you're going through and you're generating your ideas, he really encouraged us to look around the natural world. What does the natural world have to offer us? How do certain things function in the natural world? How do certain things happen? And you can get a lot of ideas and inspiration from that. So,
and he focused on the natural world, John.
Yeah.
Tell us why he thought that was a good thing to do.
Yep. So, he would start by saying, hey, of course, the earth has been around for a very long time, and you see how things happen. You might also start to understand how certain things evolve on the planet. How do certain things evolve to be the way they be? How do they adapt to the environment around them? And his teaching was, so guys, as you're doing the moonshine, you have to learn to adapt to the environment around you. What's your market situation? What are your threats, the threats from your competitors? At this point in time, we were in New England. We're in Vermont, which is not a low-cost place on the planet. We had a lot of threats from China suppliers. Go ahead.
Mm-hmm.
And so this is where he said you've got to adapt to the environment around you. And then what came almost in the same day for teaching was, so at the end of the day, the real way that you differentiate yourself and adapt to the environment around you is always through process. It always is. And he said, so guys, every machine that's made, anybody has access to the same machines. You have access to the same engineers, and you can go down the list, the same. The only thing that will be different is the creativity you bring and the intellectual capital that you put into this to make the process your own. And then what he did is he went all the way back to the early days of the Industrial Revolution, and we started to talk about, hey, before Pratt and Whitney was Pratt Whitney, it was Eli Whitney with a cotton gin, and he made his own machine. He didn't have a supplier to call and buy a machine. And he encouraged us to understand that and go down that path.
You know, when I look at, by the way, I want to remind you, John, that I want to do another episode with you all about when and how to automate. Okay.
I love that topic, Mark.
Yeah, that's a separate subject that we're going to put on the docket for a future episode because.
So just real quick, you mentioned that one of my teams that's in South Carolina, on the wall that's still there 9 months after retirement, is called the Boucher curve, which is how to understand when to automate.
Yeah.
Okay,
yeah.
let's get to it. Yep.
I've seen automation, and I'm not an engineer, John, but I've seen automation abused so badly in my time.
It's abused.
This whole thing about, hey, lights out, just go ask Elon Musk how that worked out.
In the name of productivity, it gets abused.
Yeah, in the name of productivity.
Right.
That's exactly.
Right.
But you know,
so
when you look at this natural, this thing about Nakao, looking at nature, you know, he also taught us use what's natural so you're not forcing. Like, for example, use gravity. Gravity is a natural phenomenon,
it's free.
right? It's free. Okay, so when you're doing when you're taking a part out of the machine with a Hanadashi, which is an unload device, don't automate that. Use gravity. Just push the damn thing out. Okay,
exactly.
Assuming you're not going to damage the part. And you know, it's things like that. He used snakes and water flow and birds flying, and
always. That's right.
I mean,
a monkey's. Hey, I was told. I didn't mean to interrupt you, but I was told. Do you remember when Black & Decker came out with what was the light that had had a handle you could wrap around your workstation?
Oh yeah. I remember that. Yeah.
And so he told me that came from a Kaizen event where they got the idea from a monkey's prehensile tail.
No kidding.
Yes, he told me that.
Did he run that one?
Yeah.
He did. Amazing. Amazing.
Yeah.
And by the way, I had a client in India, not our current one, but where the monkeys in the factory got to learn how to hit the green buttons on the machines, and it wasn't good. Okay. They would come down and hit the green buttons after the operator left the machine.
That's funny.
So anyway, in some cases, nature's not good, right? John, okay, so this whole business about moonshining then, talk to us briefly about, you know, what do you put in there? What are some of the ground rules about moonshine? And what is it? Are we spending, you know, $8 million on moonshine and using really expensive material? Or what are we doing, you know?
Okay. And so, Mark, I think maybe as an entry point, I'll tell my little story that was a defining moment for me.
Sure.
Because it starts to talk to who you want to attract into the moonshine shop.
Okay.
So I'll boil this down as simply as I can. So the very first moonshine event, we had a lot of teams. Was a big site, almost 2,000 people. The sensei came in, Mr. Nakao. He came with 2 interpreters that week. I had 16 teams. So it was a lot of work for everybody, myself included, for 16 teams. He didn't miss a beat. We had a lot of sub teams on one topic, which was machining some titanium. And so he wanted to teach us how to machine. We had a very fundamental approach. He didn't like it too much. He was open about that. So anyhow, we started to go through the week, and he was coaching the engineers, and they were having a hard time. So at one point, Nakao went up to the controller and started to make some changes. The engineer wasn't too happy. And what he kept telling everybody is, you're going too slow. What we had done in the preparation is we had somebody from the mill that we bought the titanium from with us, and we had a tooling supplier with us. So the guys we bought the end mills from. The machine OEM wasn't there. But anyhow, you've got all these people that are classical thinkers, let's call them. Classical thinkers, they're getting coached from Nakao. And every time he came to see them, the team, it was the same tagline: you're going too slow, you're going too slow. So feeds and speeds and RPMs, it's all too slow. So what the team did is, one of the engineers got upset. I'm sure you've experienced what I'm going to describe before. Got upset and says, I'll show this guy. And so he did some max outs. And I get, back in the day, we had pagers. So my pager goes off. I make the call. Somebody says, you better get over here right now. It's not good. So what I did is I went over, saw the team, and the end mill had a perfect friction weld to the piece part. Perfect. It was incredible. You never were going to break that bond. So it was, okay, Boucher, this is for your smart guy. It doesn't work. A few minutes later, I go get the sensei. He comes over. He didn't even have an expression on his face. The engineer stated his case. He looked at the engineer and he said, I told you it's because you're going too slow. So what I did, a lot of the team walked away at that point. This is midweek. So what I did is got with the engineer who was the best thinker. Now this is going to get to the type of people you want. And he said, you know what? What if we put another spindle in this machine that was a higher RPM spindle? So we bought a spindle, we had it flown in, and we dropped it in the milling machine. And it went to about 40,000 RPM. We were toying with 8 or 12,000. 40,000 RPM, spindle gets in. This engineer, Doug, takes the cut, and he pages me, says, you need to come over here. I said, is it good or bad? He said, you're not going to believe it. We went over there, and the piece part, the finish wasn't perfect. It was a mirror. I don't know what the RMS on it was, 5, maybe 10. The finish was almost perfect. And so when the sensei came over, no expression, he says, I told you you were going too slow. And he walked away. And so that was a defining moment for me. And the coaching that I got later wasn't for the whole team, it was for me. And he just said, Bushy, the issue here is this. It's like you guys were sailors from the old days and you thought the world was flat. You've got your end mill supplier, you've got your metals guy, you've got everybody looking at the machinery handbook. They're looking at the machinery handbook. That's analogous to the world is flat. Look right here. It says the speeds and feeds for titanium should be this. And he said, nobody ever questions, what if I go off the chart? And how fast is fast? What would happen? And he said, so you had to have the self-confidence. And then the next paragraph was telling me about Chuck Yeager. So again, he gets more to the Kelly Johnson, the airplane designer, thinking. And he said, when Chuck Yeager broke the sound barrier, there were a lot of pilots that were very close. What would happen is every time they would approach the speed of sound, the plane would buffet. It would shake and they would back off. And Chuck Yeager punched through. And he said, that's what Doug did for you today. Doug just had the self-confidence to punch through. So that was a defining moment for me with Moonshine.
It's kind of like Roger Bannister making the 4-minute mile, and everybody started doing it. Everybody said it couldn't be done. You remember that? And
Couldn't be done, right?
John, I mean, this is phenomenal. So the Moonshine, the type of people you want in the Moonshine,
Yeah.
obviously quality good engineers technically, but sometimes the great technical engineers are not the right guys to be in that, or gals to be in that Moonshine.
Yeah, actually, Mark, one of the things that I learned, I got the coaching early on, but even with getting coached from the best, you've got to learn for yourself sometimes. So a lot of the people that you might look in an org chart or somebody says there's a superstar engineer, they didn't have the mindset for Moonshine. And so the first thing that I started to notice is most engineers are what Nakao would call catalog engineers. They weren't, they had an engineering degree, they worked in engineering, but what they did is they were program managers. And they would call and organize buying things from suppliers. And so what we started to think about is you need somebody that can get their hands dirty as well. So what I started to look for, now I also didn't want to replicate people like me, a tool and die apprentice and an engineer. I love woodworking and all types of things like that. So you don't want somebody just like that, but you want people that are not afraid to get their hands on something. People know what it means to machine something. So they've got experience. And if you're a machine shop, there's other types of businesses, of course, but if you're in a machine shop, what is it like to take a chip? What is it like to program a machine? What is it like to build something? What is it like to design and build a fixture? So you need that. So now what you get into is, for me at least, I start to broaden the definition of an engineer. And the broad definition of an engineer for me might go back 100 or 120 years ago. when an engineer had a different connotation. Let's say in 120 years ago, the Industrial Revolution was what, 50 or 60 years old in the US, which started in the US in New England, by the way, the tool and die capital of the world.
That's right.
Yep. We would broaden the definition. An engineer would be a good mechanic. Yep. An engineer might be good at math. Yep. Would they understand heat transfer? Yep. So you start to think about, you want a generalist. If you can find that person, or in the cases most of the time, what I ended up doing is I would have an engineer who maybe would understand, let's say I talked about heat transfer, would understand that, is good at programming, and then match that person with a tool and die maker.
Yeah.
And then match them with a great maintenance person who can do wiring and troubleshooting and PLC. And you start to look at these different skill sets.
So you're looking at eclectic type skill sets, but everybody has a common characteristic in terms of being open-minded and being a little bit more of a risk taker.
Yeah. You need to be a risk taker. So this is the thing about the moonshine, Mark, when you're doing experiments. Let's go back to my example. So were all those engineers bad people? No, they weren't bad people. They were risk adverse. And I think that's driven by the fact that they were always catalog engineers.
Sure.
And they never really got their hands on anything. And if you don't get your hands on something, you're never going to break anything. And they were afraid of breaking something. So some of the best moonshiners are people that kind of close their eyes when you're trying something. You've got to be safe, of course, but you know what I mean.
Sure. Well, like engineers also are buying technology that anybody could buy. So there's zero competitive advantage in that regard.
Zero.
Because again, we go back to the business reason to do this. If you and I are competing against each other, you and I could lobby for the same materials. We can go after the same labor, and we can go after the same machines that are out there today.
Yep.
It's what you do with the equipment, and you design your own capabilities that gives you the competitive advantage to do flow, to do short.
Right.
And I remember Nakao telling me the only reason an engineer exists, his number one job and only, is to make the operator's job easier. Okay.
Yeah. So I had a phrase early on, and it said, engineers' pain equals operators' ease.
Yeah. Yeah, exactly. And he would check even though I wasn't an engineer, he would check my hands 3 times a day to make sure.
Yeah. Yeah. Usually it's the inverse. Usually the engineers are the one that end up punting the football.
Yeah.
And the operators bear the burden of an undone process.
The other thing he told me was, you get an engineer out of school, you put him in the dirtiest, rotten, darkest, stinkiest part of the shop, although you shouldn't have that, but let's say you did. He says, and if he's still there 2 years later, you got a good engineer.
You've got a guy. That's right.
Okay. Or gal.
That's right. Yep.
John, tell me about. Okay, so you talked earlier about the purpose of a line, or the purpose of a cell, which was to expose problems. What's the purpose of a machine?
So I love this one, Mark, because when I think about doing moonshine, I think in terms of concentric circles. So it might look like a target. And so you start in the center and work outward, and there's a sequence. So the old way, you know how I talked about new product introduction?
Right.
The old way is people would spec and buy machines. What we started to learn with the 3P, the basic thought process, and then moonshine, which is the experimentation, is you've got to define the process first. So you define the process first. How am I going to do this? How do I get this attribute? How do I do it?
How do I shave off material? How do I?
Exactly. And you exhaust all the possibilities. You do all these experiments, and the experiments can get literally into the hundreds.
Sure.
All that's done way before you think about a machine. So the progression is the process. Along the way, you're using devices to help you machine things. I know our context today is machining. That's the fixture. So how you hold the workpiece is second. The process, how am I going to do something? How do I hold the workpiece? And the purpose of the machine is to essentially house the process. It houses the process. So you get into this way of thinking that Nakao taught me, uh, always looking at the ratio of what you want the machine envelope to be compared to the part itself.
Hmm.
So what is that ratio? And for 2 decades, almost every team I coached on Moonshine, we calculated that ratio. So what happens is you might see a lot of times a part is the size of a baseball. And if you did, what's the volumetric calculation of the baseball? So 4/3 pi r cubed, volume of baseball.
We don't move that.
Then what's my machine? So, and then what's my machine? So what he cautions us is he says, hey, of course, the ideal is 1-to-1. There was a point in time where Todd and I were helping somebody in Brazil. We actually did the inverse. The machine was smaller than the part,
Really?
but that's a story.
Really?
Yeah, a story for another day. But you want to get toward that 1-to-1. Look, if it's 2-to-1, 3-to-1, incredible. Usually, Mark, what I see, what I get into is the ratio is 50,000 to 1. I've seen as high as 200,000 to 1 a few years ago. Yep. So let's think about this machine. What is it? If you first take all the sheet metal off and do what Nakao always calls strip the machine naked, get all that stuff off, get the auger for the chips off, get the tray for the coolant off, get the sheet metal doors away, get all that stuff away. What are you left with? And even then, so you're left with the ways, right? You've got some motors, you've got a controller, so on and so forth. So even then, what we were taught to do, you have a part, let's say I go back to my baseball example. Okay, what cube of the machine is my baseball and the fixture going to occupy? And you would define that. And then what you would do is you start to specialize. I know I might have 20 process steps to make my something. This process step does this. How much of the cube do I occupy doing that? And then what we started to see is on a line, each machine would be a different size because the size of the end mill you used, the size of the fixture required, might be smaller or greater, depending on what you're doing to it. But then the machine would be wrapped around that process itself. And so a good line, you would have different size machines on that line. And ideally, of course, this gets into another topic. The workpiece is always at the same height. And always at the same height. And what that does, it makes your Hanadashis easier, but then it leads you towards some simple automation later. So hopefully that answered a little bit of your question.
Use of low load, which is the chaku concept. Well, you got consistency with that. You know, John, the other thing that I learned from Nakao was he always pushed us towards single operation equipment. Although
yes, single purpose, single function.
That's right. Single function. Yep. And I actually had a situation where a client, I'm going to make up the numbers here because I can't remember what they really were, but you'll get the concept. We had 5 machines, and each of the machines had cycle times, let's say, of 2 minutes. And let's say they were under takt time. Okay, let's say takt time was 2:20, 2 minutes and 20 seconds. Okay. So our drop-off rate was, we timed the operators appropriately to the 2:20 takt time, and the drop-off rate, of course, was 1 every 2 minutes and 20 seconds, which is what it should be. I came back 6 months later and said, Mark, you have to believe this. I said, what's that? Well, we got a brand new machine, and they took me out to see it. And instead of 10 minutes of cycle time, it only is 6 minutes, but we do it all in one machine.
Yep.
I go, did your volume change at all? No. I said, okay, well, if that's the case, how's your second and third shift doing? How'd you know when to put on the second and third shift? Because you're freaking takt time 2 minutes, 2:20. And you have a 6-minute process here. You can't possibly make this in one shift. You combine everything into one equipment. And then, by the way, when something goes wrong at one of those operations, the whole damn thing is down. Where here you got that single piece of equipment that is easy to change out. So you always push it for a single operation.
So, so Mark, if I can just bolt up to that, and again, as my career progressed, my thoughts started to progress on how to think about even the early teachings from the senseis.
Sure.
So if I'm going to go back like 1 year ago or a year and a half ago, as I'm getting ready to retire, just trying to give my teams as much as I possibly can. So one of the things I was describing, the tendency that a lot of engineers have is always hold the part once, machine complete. That's a utopia for a lot of engineers.
Yeah.
So what I started to teach my team is, hey, wait a minute. The objective here is to always make a perfect part. It's deeper than that. And so what you want to do is the processes are broken up and they're specialized. A special process, a special fixture, a special machine. Even if that means there's 15 of them in a line, every one does a different something.
Yep.
So what I would tell my team, just like I have a phrase about the purpose of a line is to expose problems, what I would say is our goal is not to make a perfect part. Our goal is to make a perfect process. And the only way you can achieve that is you've got to break the process steps up according to takt time. I have 8 uses of takt time. Boucher has 8 uses of takt time. So the way I use takt time in this context is it is the rate at which the process receives feedback.
Okay.
So that's my context for this one. So that's 1 of 8. And the way that I map that out for my, let's say my better students, my better guys and women, is that, hey, you're not going to make a perfect process. You're not going to understand all the 102,000 things that could go wrong unless you do a 100% check. You have to do it, check it, do it, check it. So even when we get into the lines of code, every time we would execute a line of code, we would do a check. And so all I did is I just started to think about what's a deeper meaning of what we're trying to achieve here. And Mark, if you go back to your early example, what engineers want to do, they think the objective is I need to machine 30 of these and ship them today.
Yeah.
And while that is on one level an objective, so as an engineer and a process thinker, I try to get into a different level on, well, wait a minute. How do I over time give myself enough feedback points that I can do corrections and make this the perfect process that will always yield the perfect part?
There you go.
So I know it's a little deep.
Again, it's no different than thinking about cost first versus quality, right?
Right.
Quality will drive cost. Perfect process will drive the perfect part. Yeah. And Toyota has a saying that says, we get brilliant results with ordinary people running brilliant processes.
Yep.
Okay. And by the way, we kind of talked about it earlier. A lot of these processes are influenced by the design side of the equation.
Yes.
Okay. So we're building in quality. We're not inspecting in quality. Right.
Right.
And that's kind of what we're doing. And a lot of people who go to visit Toyota don't understand the impact that design had on that line, and
yeah, Mark, we can talk for hours about that. I think that probably at a point in time in Toyota, manufacturing had a bigger seat at the table than it does in most companies.
Yeah. And they had the monolithic engineers over there where, the guys that I've worked with over there, and they were mostly guys, or like in Hino Motors, they were design engineers, they were manufacturing engineers, they worked in purchasing, they worked in marketing.
Yep.
They were very well-rounded, eclectic backgrounds, okay?
Yep.
And even finance, and these guys really understood the whole picture.
The total cost equation.
Yeah.
Right.
Yeah.
Right.
Yeah.
The big picture. Yep.
And sales, So Nakao would call these big machines that had multiple operations, he would call them battleships.
Yeah.
And he said, you need to have PT boats.
Yeah.
Maybe a lot of people don't remember what a PT boat was. John F. Kennedy ran one, and
he did.
Remember McHale's Navy, the comedy show, the sitcom from I guess the 60s.
I remember watching that on cable when I was little after school.
The PT boat was a small little maneuverable boats. He said we need PT boats, not battleships, right? And so that really was the issue there. And then maybe the last thing I want to talk about, this moonshine room. It again, to go back on what moonshine is, it's a dedicated area where all kinds of thoughts and creativity and experimentation happens. And you're using things like sheet metal, you're using cardboard, you're using plywood, you're doing all these mock-ups
Yep.
very low cost, and
Yep.
you've got all the right equipment in there. And depending on the business, you need to have the right type of equipment in there,
Yep.
depending on what it is you do, whether it's a mill, a lathe, or whatever. But this moonshine room, John, is where all these handful of engineers that are handpicked, as you described, get in there. We shut the door. Tell me about the management of that room, or lack thereof.
Mark, it's a great question. So maybe what I do is I go back to the first time I ever heard the term. What Nakao said is that, hey, you need to go under the cover of darkness like the Kentucky Moonshiners, and he stated the
Right.
reasons.
Right.
So what happens is that leaders, for the right reasons, Mark, leaders are impatient. And as soon as they hear that somebody's on the verge of a breakthrough, or I might get more productivity from something new I'm hearing about, they're going to force that to go into production. And so what happens is nobody ever has ill intent, but they end up damaging the system that we're trying to create. So I think the trick is how do the leaders understand what's going to be worked on? And then what is your daily management or your operating mechanisms for the moonshine shop? So I got a couple thoughts. So one, to me, it works best when the topic itself, not the solution, but the topic, is part of the Hoshin planning. So what you're always talking about with moonshine at breakthroughs, this is the kaikaku space, which is the step function change, as opposed to the kaizen, which is incremental change.
There you go.
So with the step function change, what you're doing is you have a team with a self-confidence to throw the old process away. But in production, the old process is still going on in production, and it's being kaizen. Parallel path, kaikaku with the moonshine. So what you want is a space in a team that is self-directed. It's always a self-directed team. So again, you're back to what type of personality or what are the attributes of the people that you want in your team. But also for the next piece here, maybe the best reference point, Mark, is an article that I think I know you and I have read a million times, but Decoding the DNA of the Toyota Production System.
Yep, I'm friends with Steve Spear. Yeah, I work with him.
Great guy. Yep, and I think Kent Bowen was an author that wrote a lot about this too. So in there, they've got in that DNA article the 4 rules, and one of them is, I'm going to paraphrase it, but all the improvement is made under the guidance of a teacher working at the lowest level possible in the organization. Self-directed work team plus the coach. And it has to be an experienced coach. And like every good coach, they know when to coach, when to put your arm around someone, and when to give somebody space. And so you can't be looking over somebody's shoulder thinking you know the answer to everything. So what I coach on is not creativity. I coach on the framework. How did you set your experiments up? Show me what's your hypothesis here? Show me how you're going to set the experiment up. Do you need an apparatus? Can you do it without an apparatus? How are you going to know if the outcome of your experiment is good or bad? Have you thought about that? So I coach on that type of a process, and then get out of their way on creativity.
Yeah, it's incredible, the power of this thing, because I've seen it firsthand. As you know. And by the way, one of the things about moonshine too is, I know we talked about Edison and what have you. Nakao told me that, in the moonshine, when Prohibition came about, all these moonshine distilleries got put together in the backwoods somewhere down south, and you got, a garden hose and a garbage can and all kinds of stuff like that got put together to create these stills, right?
Yeah.
But one of the things that was interesting about moonshine, or many people may not know, maybe many do, is that's where NASCAR got developed, because they had to rev up their cars to beat the state police over the state line.
Yeah.
And it's where the whole sport of NASCAR came out of the Prohibition and moonshining. So
Crazy,
then it's another kaikaku, right? I mean,
That's right. That's right.
I thought that was kind of a nice parallel there,
Yep.
John, this was great. I think there's so much. I know there's so much more to talk about it, and it's too bad you're not passionate about this.
It's too bad, Mark. Even in retirement.
Yeah, exactly.
Well, I'm not retired.
Come on, you're working with Lean Horizons here. So, John,
That's right.
I would like to have you back 2 different sessions at least. Okay. One, I just want to have a discussion with you about automation
Yeah.
and how to think about this. Is so misguided today. Everybody's going out there buying robots. I could kill them for doing that. And there's a time and a place for automation. You have a process to think about. Maybe we can even show it on the
I
screen.
do.
Okay.
I do.
I
Yep.
want to talk about that. And I want to have another session with you just to talk about Nakao. Okay. He's so special. I actually wrote a poem about Nakao. I'm not going to read it now. I'll save it for that session. But I was thinking about doing a session on Nakao anyway. But who better to have with me to do that is you. And we could talk about some of the anecdotes that he's done and some of the things that he pulled over the years. Some away from the factory, sometimes in a sushi restaurant. And he
They're all, I'm just smiling, Mark. They're all great stories.
oh my God, maybe we can plan a few sessions for that one.
And I've got
But
some of my own that he did in our shops. Yeah.
yeah, I'd like to have you back on that too and talk about that. So look, let's end it here for now, John. I know there's a million things more to talk about in this space, but the whole 3P and moonshining concept is something that we're implementing now with a couple of our clients, and you're leading that. And this, to me, is the unsung part of lean that nobody knows about.
Yeah.
And if we get our heads out of our, you know what, and get away from these Gemba boards and start thinking about some real process improvements. Because, you know, again, I want to go back to the respect for people part of this. If we are expecting through a lean transformation all these great improvements, but we don't provide the framework as leaders for our people to be successful, then how does that work? That's just damn disrespectful. Okay.
Yeah. Hey, I'm looking forward to talking to you about that. The way I think about it is the scoreboard doesn't play the ball game for you.
No.
Yeah. Yeah.
No, and
We
you know,
should
and a
talk
lot
a
of,
lot
and
more
again,
about this.
I think we're going to do a whole second session on Gemba boards because, and I do have one of my problem solving module episodes earlier on was about leading and lagging indicators, and most of the time we're looking at lagging indicators, not leading indicators on these boards. And many times these Gemba board meetings are, hey, Charlie, is that part going to be? Yeah, the part's going to be in at 2:00, Joe.
That's right.
We'll have that machine up and running at 3. Okay,
That's right.
expedited meetings. They're not.
That's right.
They're not really improvement meetings, and
Yeah.
everybody's standing around pretending that
That's right.
pretending to
That's
do
right.
it, and nobody wants to tell the emperor.
The herd of sheep.
was.
Yeah.
Right. And so maybe a whole separate section on Gemba boards to get it our thinking.
So we have at least a couple more to do then, Mark.
We do, you know, and again, Gemba boards, I'm not trying to diss Gemba boards. I just reject how they're being done. And I also just did an episode. Well, actually, it's going to come out after this one. Whatever happened to Kaizen? Because nobody's doing Kaizen anymore. So we still got to do Kaizen on existing processes. What we're talking about here is challenging the status quo, because if you've got something that's suboptimal to begin with, and you try to improve it through Kaizen, you're all you're doing is getting better at something that's still suboptimal. And so the whole idea with Moonshine is to create something out of the box that's optimal. Not to say you won't continue to improve it.
That's right.
But you've
Then
got
you Kaizen it. Right.
then you Kaizen it, because you want to break away from, you know, traditional thinking. I'll go back one more time on my experience with equipment manufacturers, where they want to sell you the next big increment of capacity. They don't want to sell you small pieces of capacity. They want to show you that $5 million machine, and they don't want you to change over quickly. They don't want you to be flexible. They don't want you. Okay.
Because they want to sell more machines. Exactly, Mark.
That's exactly how it works, right? So the equipment manufacturers in general are just counter to the whole philosophy of.
I think we're their worst enemies.
Oh yeah, no, they wouldn't like you. They wouldn't like you. No, seriously. I mean, you know, and again, I'm going to go back to I had a client once that made blades, mid-sized blades for aircraft engines, and it wasn't GE. And the blade was about, I don't know, 18, 20 inches long.
Mhm.
Okay. And the machine, John, was as big as the footprint of my first house when I got married. Okay.
Amazing.
And
And
I
that's
mean,
common.
it was that
Yep.
big. It was that big, right? With all the coolant and all the other things that
Yep.
chip mobile systems and everything else. It was like, oh my God, you have to make a little part. And I remember Nakao saying to me, little part, big machine, right?
No
And so-
good.
No,
No good.
And gee, no good. Anyway, okay. I'll tell you
Okay.
what, let's end it here. This has been phenomenal. And I hope people really listen to this and understand that there's a part of lean here that nobody's talking
Mm.
about.
That's true.
They're all talking about Gemba boards and yellow tape and posters and T-shirts. Okay, we're not doing standard work. We're not doing Kaizen. Nobody's doing it that I could see doing it well, at least. And this part here, forget it. Right. So
Yep.
anyway, John, thank you.
Okay,
John,
Mark.
Managing Director, Lean Horizons. We got to get back to work, right, John? And
We do.
and thank you very much. And we'll get you back on again for automation. What to automate? We'll talk about Nakao in another episode, and we'll go from there. So this was
I'm looking forward to it.
episode. This is episode 28. Okay, the Lean 911 podcast. If you guys have any comments or questions, email me at Mark M-A-R-K at lean911.com. Mark at lean911.com, and you can find us this podcast on lean911.com. All the episodes are listed. We do 2 a month. And right now, at least, we do 2 a month. And we are also on Apple Podcasts, Spotify. You'll find us on the YouTube channel. Subscribe there. And we'll see you guys next time. I appreciate it. Thank you.
Thank you, Mark.
Okay. You bet.
Bye.
Thanks for listening to the Lean 911 podcast. I'll be happy to address your questions or feedback on future episodes. Email me at mark@lean911.com. You can check out our other episodes by visiting our website at lean911.com, our YouTube channel, wherever you listen to podcasts. This is your host, Mark DeLuzio. Thanks for listening.